we will have this panel discussion. We have all these experts here, and we will have firstly, before deep diving into technical questions, just one round of little bit insight into what is some exciting and significant work that your organization is doing in this transition. And further than that, we will have 1 or 2 round of questions from moderators, and then we will open the floor to the audience. So starting with Mr. Sunil Bhatnagar sir, one interesting insight I was reading about him, he started his career as a Air Force pilot, and now he's piloting the ZET transition to new skies. So over to you, sir, and subsequently to other panelists. Just brief in 2 minutes what you are doing and some exciting work.
Yeah, hi. See, we are giving a shape to this transition. We are the first one in India who made 55-ton electric truck. We started this project around 4.5 years back when people were thinking how to go about it. We launched it around 2.5 years back after homologation. And a lot of trucks are running in mining and other areas of heavy construction and all that. So we are practically doing it. We are practically contributing to zero emission transition, and we are making the heavy duty trucks of 55 ton. So that is about our company.
So my name is Ajay and I'm representing Switch Labs. So we are actually deploying EV trucks in full stack mode. Like we are deploying and we are integrating these heavy duty EV trucks with cement and metal and port companies. And transition is as smooth as deploying a diesel truck. Means like we are taking care of charging infra, drivers, management, assets, utilization, everything. So we have already deployed 2 trucks with a cement company in state of Gujarat. And by end of this financial year, we have a target to deploy at least 100 medium and heavy duty EV trucks on road.
Hello everyone, my name is Samhita Shiledar. I'm the Global Director with RMI. RMI is a think tank working in the field of energy efficiency for different end-use sectors. Particularly within zero-emission trucking, we are actually partnering with a lot of different industry stakeholders that are over here, as well as different national and state-level government agencies. Most prominently, we have partnerships with Indian Ports Association, as well as Telangana and now Tamil Nadu government in terms of fast-tracking zero-emission trucking deployment. Apart from that, we are also working with Principal Scientific Advisories Office, COZET, P-Manifold, and NHEV on various topics with respect to zero-emission trucking, ranging from corridor identification and development, as well as zero-emission trucking financing and policy development.
Good afternoon, everyone. My name is Raghavendra Maiso. I'm one of the co-founders of Move Technologies. We are into deployment of electric heavy-duty trucks and charging infrastructure for regional haul segments. We have priorly been focusing on the short haul, let's say sub 200 kind of range segments. Yeah, exciting to be part of this session and happy to answer any questions as we go along. Thank you.
Good morning. I'm Sundareshan from Ashok Leyland. So as along with our subsidiary Switch Mobility, we build and supply electric buses and trucks all the way from 2.5 ton GVW all the way till 55 ton GVW. But being a traditional player, we are into other zero emission or lower carbon footprint vehicles as well. I mean, whether name it LNG or CNG, hydrogen, ICE, fuel cell, methanol, ethanol blends, and biofuels, everything. But as Karthik mentioned earlier, we are keeping all the, we are experimenting with all the technologies. And again, as of now, I think the technology that can be put on the road today is EV, both in terms of technical and in terms of commercial viability. Excited to be part of this, and let's hope that we have more electric trucks on the road soon. Thanks.
Thanks. Now we will switch to online. Atul.
Hello, everyone. I've been asked to speak about the role of relay trucking model in facilitating transition to zero emission trucks. So probably I'll just speak to that. See, honestly, I feel it's quite an early conversation for us on tractor trailer trucks, specifically with an electric configuration. right? Knowing that the relay trucks, essentially, even in the conventional diesel forms, haven't been able to maximize their potential, haven't they? Right. Having said all of that, I personally also see that there are a lot of parallels with battery swapping, so to say. But I wouldn't want to endorse one over the other, at least at this point, when we know so little about how each of these models and configurations are going to play out. But I'm pleased to know that there are friends from the swapping industry who would probably throw some light on the configuration as well, which is on the swapping model. What's also I feel important for us to note that the annual sales of a typical relay model or a tractor and a trailer truck model have fluctuated typically between 10% to 25% of sales on an annual basis. Now, this of course tells us that the rigid form of vehicles in India, of course, are sold more and are preferred in some shape and form. So there is a bit of that dynamic which is also playing. While we start thinking about tractor trailer models, we also need to understand that there is an inherent bias towards rigid trucks. And of course, there are several factors that are playing to it. Now, coming back to the fundamental question of how tractor trailers with and relay trucks with an electric configuration can help. One is, of course, as rightly put by Vikrant in his presentation, it offers us the flexibility to break the journey, and that is essentially the essence of everything that can work in its favor. It helps us to break the journey in several smaller parts, where the tractor can be detached and a fresh tractor with a fresh battery can essentially be applied. Now, what does that do is one, it helps us to optimize the size of the battery on the vehicle and therefore avoiding larger capacities of battery. Second, it helps us to reduce the ideal time, as so to say, the downtime, so to say, and of course, compared to that of the truck, a traditional truck, where you would probably need to allow the truck to also charge through regular charging. Of course, a tractor trailer offers that benefit over regular charging because it reduces the idle time, right? In that sense. And then, of course, it obviates the requirement of any form of desk charging infrastructure that would be needed. Now, the other important benefit of also, working with the tractor and trailer trucks is that while it offers the flexibility to break the journey, it also allows you to choose a tractor of a certain battery capacity. Now, this a tractor can be selected on the basis of the duty and the gradient of the road itself, right? So for some patches of the journey might need a certain kind of a duty, and hence it might demand a certain kind of a lower energy requirement or a higher energy requirement, right? Overall, in our experience of as the climate group, as we have worked across several projects and are also working with several member companies, including JSW, Flipkart, and IKEA. The sentiment across all the work that we are doing with these three companies is that there is no compromise on three things. The first being speed, second being reliability, which comes through the vehicle design and the configuration, and third is essentially the cost, right? And I think it's fair for us to say today that we don't know enough about the tractor trailer configuration and how it will perform with an electric kind of battery sitting on. So clearly there needs a bit of an evaluation from our side on the impact of not just understanding the impact of total time required compared to the conventional diesel, but also battery swapping, which of course is a potential configuration as well. Not just that, I think one final thing that we also need to investigate is how does the total cost of ownership change in the light of several factors if you were to kind of go to the tractor trailer, right? So for example, one a relay model will need additional space to house all the spare tractors, right, at the relay swapping station. So what about that cost of also having that additional space to have so many tractors available as well on a standby network? Then also knowing the implication of, say, reduced and added manpower cost as a part of the entire relay as well. And last but not the least, there could be also other factors such as changes in the potential modifications and changes in the cabin design. Also knowing that we might not need the additional space for an assistant driver for shorter journeys, because of course the journeys themselves have, and hence you might need compact designs as well. So I think I'll probably pause there and wait for any questions as well if there are. But these were the broader reflections that I had. Thank you.
Thanks, Atul, for giving us insights on these pros and cons of the relay model. And you rightly mentioned, so tractor trailer is actually less in terms of overall sales. But one interesting thing is all the developed countries, the phenomena is they shift to more and more larger and larger wheelbase vehicles, because that becomes more cost effective on per ton basis. So India will also be seeing that. Okay, on that reflection, I hand over to Basha for our first question.
Yeah, so now that we have the truck operators on the dais, let us understand from them what are they doing and how, what kind of challenges they are facing, because they are the real people who are deploying the different technologies that we speak about or we do a study on. So my first question to Ajay and Raghavendra, maybe one after the other, you can answer. So, in terms of support that is required from the government for regulations to be developed, or the regulations that we need to have this flexibility of interchangeability of the tractor and trailer. So I want to know about what kind of regulations are required, and probably whatever is in your wish list, maybe not available today or maybe no one is talking about, but please give us your wish list.
Specifically to the tractor trailer, the first question that comes in, which I am sure government is already trying to address, is the mismatch that we see with the registration of the tractor and the trailer separately, right? As far as I understand, current norms allow us to use only certain number of trailers for a specific tractor. But the moment we talk about relay kind of a model, how flexibly can we, swap the trailer itself is a first question that will need to be answered, and they'll definitely need some policy support on that. And secondly, coming specifically to the EV, EV trucks specifically, not just for the tractor trailer. It's great that companies like IPLT, Ashok Leyland have already taken the lead in terms of manufacturing the vehicles. But in terms of actually operationalizing it, getting the financing done, is still, we are still in early stages, on those aspects. So any government strong support, which we are hoping from the FAME 3, we hope that some of those points can be addressed there.
So on tractor trailer model, we know that like tractors and trailer can be registered separately, but means like though it is there is a notification from respective government departments, but in practically some of the states are not allowing it. Means it is in purview of local RTOs and local state authorities, and so if there will be a like there will be a state support also needed on the policy level, because it's a completely RTO and local phenomena, not a national phenomena. Second, uh, EV trucking as a whole required a lot of government support, and especially the financing side. It should be under PSL. Means like I don't know why it is being delayed, but it should be under PSL. Then only the government banks will come forward and go for financing. Obviously, and on the policy side, I think the all hard to abate segment, there should be a EV purchase obligation should be introduced in a phase-wise manner, starting with a lesser than 1% and then go on and on, which will compel these all hard to abate segment industries to at least, because anyway they are not going to own these assets. And as of now, today also they are not owning these assets. In tomorrow also they are going to, like any third party like us or someone like a traditional transporter is going to operate for them. Uh, in my view, like if there is a, like, if there will be a policy hook, uh, like a EVPO, they are going to transition for it, and that will simplify things. That will give a enough, like, I took a lot of inspiration from solar. In solar, in 2009, when GNSM was announced, our target was just 22 gigawatt by 2022. But when this, in 2014, Modi government came and they enhanced the target by 100 gigawatt by 2022 only, and which result in, like, we achieved this 22 gigawatt of solar installed capacity in 2018 only. Means 4 years earlier than the previous set target. So if, and that happens through, like a renewable purchase obligation kind of policy. So I'm in very strong favor that if government comes with a EVPO policy with a certain hard to abate segment, industries, designated entities, it will be really helpful.
Thanks, Ajay. We are also hopeful for the incentive as well as some kind of purchase obligation if it comes. My next question will be to Sunil ji as well as Raghavinder ji. So we have been hearing about batteries and their cost. But my question comes around, so we discussed in the morning, NMC is a no-go, LFP can be a solution. So what are the options going forward in the near and long term? And what are your views on battery swapping as one of the solutions?
Yeah, see, there are 3, 4 technologies in lithium what are going on, and the most prominent is the LFP, the lithium iron phosphate. In nickel, manganese, cobalt technology, the energy density is very good because the cell voltage is 3.7, whereas in LFP, the cell voltage is 3.2. So energy density is a issue, but LFP is very safe, seeing to Indian conditions of high temperature and all that. So most of the companies where space is not a problem, like in our electric trucks, we put the battery between the cabin and the trailer. So there is a lot of space in between. So space is not a constant here. So we use LFP. So that is a very good technology. But if you take a case of a scooter where energy density is an issue, you can't go for LFP in that. And mostly people are using NMC there. So the third technology is LTO, where the energy density is more poor and it is close to 2.3 or 2.4 only. But that has a very big plus point of fast charging. So all the technologies have different plus and minus points, and depending on the use case, you go accordingly. There are many other technologies, new technologies are coming like supercapacitors, and so many things are coming. Even sodium ion is coming. So there are so many technologies which people are working, and things are moving on. And the biggest challenge is of energy density, which I think to a large extent it is now being solved in LFP, because what people have done, they have added manganese in it, and now it is LMFP. With LMFP, the system voltage is improved, the energy density is improved, the cost has reduced further. So all these positive developments are happening, and it is good for industry. Further, the prices are also coming down. For in last 2 years, we are seeing continuously the prices are coming down for lithium. So another good point for the industry.
Nothing more to add to what Sunil mentioned. See, this thing is, one is safety at the cell level, another is at the pack level, and then the vehicle level. So, of course, NMC is dangerous, but then you can design a battery pack in such a way that the pack is safe, and then you can mount it on the vehicle again in such a way that the vehicle is a lot safer. Same goes with LFP or LTO. Of course, ideal solution would be a cell that is safe, but again, through proper design, it can be addressed.
Thanks, sir. So on the second part on the battery swapping, so we were having some trials earlier as a country, not ICCT. So we were having these trials for buses, and there was battery swapping involved.
Vehicles, they operate in a very dusty environment. So because of that, that further compounds the wear and tear. We hear that now at least there are connectors which are better. And already I think some trials have restarted both in buses and trucks. And we do hope, again, the problems get resolved because battery swapping is a good solution.
Aviral, just one question I want from the panel is because this particular panel is very, very important for right now. Entire nation looking at how do we minimize the downtime. There are various possibilities. Panel discussion may end today, now, because of time constraint and other thing. But Sundaresan sir, we are going to conduct these trials with your trucks in 1 month. You have given 2 wonderful, huge trucks. And all these possibilities that we have discussed here, is it possible for us to at least arrive on a evidence-based mechanism to look into opportunity that what challenges might have came if we try to do tractor trailer or anything else? It may not be technically possible to develop a truck and give it to us for trial, but at least capabilities and precision of machinery which is available on our hand can be prototyped or can be kept in a way that end of the trial at least we have some answer to give them a concrete conclusion that how do we go for the downtime possible aspiration at the nationwide we are seeing. All of you can add couple of words to it. What I want is because this is my need and nation wants to know how you will be able to contribute into it. All of you are not only committed till this panel discussion, you have to work with me for next 1 month to get me an answer to it. Over to you.
Can I start? Okay. See, here in electric trucks, or you talk of any electric vehicle, because the upfront cost is very high. So you have to use it to the maximum time. So if you are using the asset, then your payback is very fast, and then only the model is successful. So we say TCO. So your total cost of operation should come down if you do more number of kilometers with the same asset. So in general, if you talk of the trucking, what the ICE trucks are doing, that is generally close to 200 to 300 kilometers only per day. That is the average, which as per many reports. But in electric, it becomes very easy to do even 600 to 800 kilometer per day because of the high efficiency of the electric truck, because of the low temperature in the cabin, because you don't have any engine or something like that. The powertrain and your battery, everything is liquid cooled, so temperature is not high. So your efficiency increases, and with the motor you have extra power. Like our company makes use a motor which has a 360 horsepower of the capacity. So in ICE you will generally see it is coming to 250 or 280 or something close to that. So here the gradient is more, power is more, running is easy, so you can do it much more. Second technology is about the swapping. At IPLT, we have done swapping in our trucks. Our truck battery is 258 kilowatt hour and battery weight is 2 ton. It is a very heavy battery, so it can't be managed like that. So we have done swapping and we have developed a swapping equipment where we do swapping in 7 minutes. We take out the old battery and put a new battery in 7 minutes. So the downtime is very low in that case.
But you are giving information on a wrong platform.
Yeah.
I'll come back to you with all technical details and you will have to provide me. You have not given me truck, you will have to give me all details of swapping and fast charging. Both of these.
Definitely.
Me and Smita is committed to deliver a report on this,
Yeah.
and we need this information.
Now, our trucks are running already for last 2.5 years. We have supplied more than 150 trucks to different mines and ports and construction industry. Cement industry is the biggest user. We have given to steel companies. So we have already done trials by our own, and one of the truck has crossed 3 lakh kilometers already of running. So it is very successful technology, I can tell you. We are very confident of it, and the prices are coming down, fast charging is happening, so the asset can be utilized very well.
Sure.
Thanks, sir.
Let us have Samhita here because they have conducted a study on looking into 8 different technologies on the corridor approach in the Delhi-Jaipur corridor.
Yes.
So Samhita, please throw some lights on your study and probably you will be able to answer what Abhijeet sir asked just now.
No, thank you so much, Barsha. So, as Barsha mentioned, we have conducted a study in partnership with Principal Scientific Advisory's office, where we have compared 8 different technologies for Delhi-Jaipur corridor. This includes slow charging, fast charging, ultra fast charging, hydrogen, hydrogenized, as well as catenary and induction. So as Abhijeet sir rightly pointed, one of the critical barriers to zero emission trucking adoption, or one of the main point of anxiety for most of the drivers as well as industry players, is with respect to high dwell time, which is where combination of certain technologies could also come in play, in terms of what is the use case, what is the length of the corridor. Relay model is definitely one of the options in terms of having a same start and end point for the trucking driver, and it could also have multiple benefits, right from improving the quality of life of the drivers themselves. But apart from that, swapping can reduce the dwell time to almost less than 10 minutes. Combination of depot and fast charging is also a very good solution, especially for medium length corridors. So at the start and end point, having slow chargers, and in the middle of the route having fast or ultra fast chargers. And then again, hydrogen technology reduces dwell time substantially. So especially for long corridors with high paid load, hydrogen technology could also emerge as one of the solutions. In some of the parts of Europe, there are also very short trials that are being conducted on using catenary and induction for on-route charging, and that is also one of the solutions being considered by PSA as well as MORTH. So that's the variety of technology options, but it all boils down to the use case and the type of the load and the distance and the
So
That's
we
so
can
nice of
have
you.
one or two questions because we are running short on time.
Swamiji, only one question. We're running very pressed on the timeline. We have a huge, amazing campaign session coming up on Shunya.
My name is Swami Prem Anvesi. And my question is, when we are discussing here for ZET, zero emission, why we are not discussing about the highways which can be designed with the induction, where there is no need for us to go for battery swapping and all. No one has mentioned even all those 8 technologies that we can go for induction. We can use the existing trucks and diesel and petrol trucks, allow them to put the magnets and they can charge the induction highways. Why we are not discussing? Why we are thinking only the way Europe or America thinks? Why we are not going out of the box? My question ends here.
I can quickly take this up. So catenary and induction were actually two of the technologies that we studied. Definitely there are pros in terms of if there are lots of trucks running on the ground, and if the route is medium length, then these technologies definitely make sense. But the upfront cost for these technologies is so high, and there are also lots of operational challenges. And these technologies have to be combined with slower fast charging, because the truck has to leave with the full charge and has to get fully charged at the end point. And in between, there can be stretches of catenary or induction, which can be the overhead wires, otherwise underground magnetic coils.
So what Swamiji was saying, see, this is one is pantograph charging where you do from overhead. Another is your wireless charging where you lay the bed below the road, around 1 inch below the road, and then you have adapter in your vehicle which will take from the magnetic emission out of that. Now see, these technologies are very expensive as of now. We are selling our truck 1 crore plus, and it is not selling because the price is so high compared to ICE. The ICE truck which is coming in our category is close to only 40 lakh rupees or 45 lakh rupees. So pitching a electric truck against that is itself 2.5 times the cost. Now I go for wireless charging, it will go to 3 times. So without any this thing incentive from the government, because FAME 1 and FAME 2 was basically for mass rapid transportation, and government has taken a lot of consideration for the passengers. So electric buses came in and electric taxis came in and like that. But trucks were not considered. Now in FAME 3, if trucks are considered, then further technologies can be considered. India is capable of adapting all kind of technologies, but upfront cost is to be seen. Thank you.
So much, sir. Now in this panel, we have heard that there are lots of different technologies which has their own challenges. They come with their own advantages. But what is important is we need to minimize the downtime, and we need to look into each and every possible solution which helps us in minimizing the downtime, because it is not only favorable for electrification but also helps us in reducing the logistics costs, which we heard in the first panel that is something which India is lagging behind. So with that, I would like to thank all the panelists here and NHEV for giving us the opportunity for having this panel here.